In this video, I'm going to go through the answers to pages 158 and 159. Again, you can always replay, hit pause, go back through to review material. And if something still doesn't make sense, please email or send me a text to remind, just to make sure that it makes sense when we're done. The next problem, the rate of change describes the amount that the dependent variable changes for every 1 unit that the independent variable changes. Again, the unit rate is, in essence, a slope with 1 as a denominator. So it's a slope with a whole number, a 1 below. And so, actually, it can be a fraction up above, but it has 1 as the denominator per 1 unit. We're talking about feet, the dependent variable, feet and depth, the depth, in time and minutes. So how far down does the submarine go per 1 minute is the unit rate. And as we saw in the previous, it goes down 480 feet in 1 minute. That is the unit rate. And again, it's per 1 unit of time, or per 1 unit, whatever the bottom number is. It can be price per pound, dollars per gallon, miles per 1 hour, but it's per 1 unit. How deep will the submarine be after 2.5 minutes? Well, when time is 2.5 minutes, we're using the equation. Depth is negative 480 feet per minute. That's how far it's going down per minute. So we're putting 2.5 in for our time. Negative 480 times 2.5 is negative 1,200 feet. That's the same as 1,200 feet below sea level. So the negative means below sea level. We would often, when we say depth, it makes more sense in our conversation to say below sea level as opposed to a negative. But either one of those answers works. 90 seconds. Well, we've been dealing with time in minutes, not seconds. So we have to convert seconds into minutes. Again, I can set up my fancy 1. I have my 90 seconds, and then I'm just multiplying it by a fancy 1. Seconds is in the numerator, so to cancel, I need seconds in the denominator. 60 seconds is 1 minute. Any number divided by itself is 1. And in this case, since these two look different, 1 minute versus 60 seconds, it's a fancy 1. Well, when I multiply, second cancels second. 90 times 1 is 90. 1 times 60 is 60. 90 divided by 60 is 1.5. And minute is the unit left over. So 90 seconds is a minute and a half. If I put a minute and a half in for t, negative 480 times 1.5, I am negative 720 feet, or I could have written 720 feet below sea level. 45 seconds. Again, I'm going to use a fancy 1 to convert it to minutes. And seconds is in the numerator, so I needed to cross-cancel with seconds in the denominator. Seconds cancel seconds, and I'm left with minutes. 45 times 1 is 45. 1 times 60 is 60. 45 divided by 60 is 0.75. So 3/4 or 0.75 of a minute. 0.75 minutes times negative 480 feet per minute is negative 360 feet, or 360 feet below sea level. How many minutes would it take deep flight to be at? So in this, they're giving us D, because again, our equation is depth equals negative 480 multiplied by time. In this case, they're giving us the depth, and they're asking us to solve T. So negative 1,400 feet below sea level is negative 1,400 equals negative 480 times T. Divide both sides by negative 480, division property of equality, and I get negative divided by negative is positive. 480 divided by 480 is 1. 1t is approximately 2.92. It came out to 2.91666, blah, blah, blah. So I rounded, and I use this squiggly equal sign, which means approximately. So approximately 2.92 minutes. How many minutes would it take to reach 2,100 feet below sea level? So negative 2,100 equals negative 480 times t. Again, I'm dividing by a negative 480, and I get t equals 4.375 minutes, so a little more than 4 minutes. Construct a graph. My graph was messy because initially I put in my 0, 0. At 0 minutes, we're at sea level, so we're at 0 feet. And then obviously we're going down, we're getting deeper. Initially, I made a mistake of putting my 6 minutes on the 6.5 minute line, so I had to redo it in red. At 6 minutes, the line that comes down in 6, we're at negative 2880. So we're a little lower than the 2800. We're a little deeper in the water. 5 minutes, 5 minutes would come down from up here, is negative 2400 feet. So a little bit above the negative 2450. 4 minutes is at negative 1920. 3 minutes is at negative 1440. 2 minutes is at negative 960. 1 minute is at negative 480. So again, each of these rates, the x gets listed first in a coordinate pair. The y value gets listed second. And so when time is 0, depth is 0. It's at sea level. When time is 1 minute, depth is negative 480. When time is at 2 minutes, when x is 2, y is negative 960, and so forth. So that's what the graph would look like, the one in red. Again, if you have any questions on those problems, please contact me. We'll go through it. Good luck.